To be able to launch our bird, we will have to begin by implementing some basic requirements. And to start, I will go into our configuration file, where we will now add physics categories to be able to properly work with physics and physics bodies in our game. I will add this above the extension for CGPoint as a struct called physics category. I will add my different categories as type constants, beginning with static let none, as in uint32 with the value 0. Static let all with the type uint32, which will get the value uint32.max, and static let edge as uint32, which will be a 0x1. This will be the category for our game borders. Static let bird as uint32, which will be 0x1, bit shifted to the left by 1, and static let block as uint32, which will be 0x1 bit shifted by 2. We will use this block category for any obstacles in our game. And we might come back to the struct though, if we will need any further categories later. For now, this should do, and I will, before going back to the game scene, quickly edit our bird class once more. Right after grabbed, I will add another variable property called flying, which will also initially be false. This property will contain the information if our bird is currently launched and therefore flying. If that is the case, we obviously want to react to it. So to easily do that, I will add a did set observer to this property. In this observer, I can then write if flying to check whether the value is currently true. And if this is the case, and we've therefore launched our bird, I want to make sure the physics body of our bird is dynamic and therefore influenced by forces such as gravity. So I'll write physics body dot is dynamic and set it to true. I can do this without any concern here, since if this is written with the optional chaining with the question mark, it won't produce a runtime error if the physics body property would be nil, even though it shouldn't really happen in the game. If I now set the flying property on a bird node to true in the game scene, it will simultaneously make its physics body dynamic. We can then go back to the game scene file, where I will now add something to the addBird method right here. What I want to do now is actually add a physics body to my bird so that we are able to interact with it and influence it. Right at the top, I'll write bird.physicsBody and I will set it to a new skPhysicsBody instance. For the initializer, I will choose the rectangle of size for now, and for the size, I will obviously pass bird.size, so just the size of our node. I now want to set the category bitmask, contact test bitmask, as well as collision bitmask properties on the newly created physics body. Beginning with the bird.physicsBody.category bitmask, which will of course be physics category.bird. Bird.physicsBody.contact test bitmask will be set to physics category.all to just check for contact with any other physics bodies for our bird. Finally, I will set the bird.physicsBody.collision bitmask, which I will set to physics category.block, bitwise or physics category.edge to collide with blocks as well as borders of our game. So basically that we don't drop out of the game. I will also initially make this body static by writing bird.physicsBody.isDynamic and setting it to false. This will make sure that our bird is not influenced by forces or gravity to begin with, since it shouldn't just drop down from its anchor point because of gravity. We can then go back to our touchEsEnded method, where we as of now just set bird.grab to false. I'll begin by right below setting bird.flying to true, which will, if you remember, also set the physics body to dynamic, so it will be influenced by gravity, and it can be influenced by other forces as well. We now want to use such a force to apply an impulse to our bird. The force of this impulse should depend on how far from the anchor, so from the starting position, we have dragged the bird. I'll define two constants for this, starting with dx, which will be set to anchor.position.x minus bird.position.x. And then dy as anchor.position.y minus bird.position.y. This will just give me the distance from my bird to the anchor point for both the x and y values. I can then use these two values for the impulse that I want to apply to my bird. It will be a constant called impulse, which I will have to initialize as a CG vector. This vector will get a dx and dy parameter, which will just specify the force of the impulse in each direction. I will of course just pass dx and dy for these values. Finally, I'm able to use my impulse by writing bird.physicsbody.applyImpulse, where I will have to pass a vector. So I'll just add impulse. I will also write bird.isUserInteractionEnabled, which I will now set to false, since once launched, we should not be able to move our bird manually anymore. We've now solved the problem that our bird should be launched when we let go. We still have the problem that our bird only should be draggable within a certain radius around our anchor point. And to implement that, I will add a new method to my class. Right below add bird. And I'm going to call it constraint to anchor with a parameter active of type bool. Depending on whether I get true or false passed to this method, I want to activate or deactivate a constraint that prohibits our bird from moving too far away from the anchor. So let's begin by checking if active, and if this is true, I will define a sling range constant, which will be a SK range with a lower and an upper limit. For the lower limit, I will pass 0.0, since this limit will be our bird being right on the anchor's position. For the upper limit, I will say bird.size.width times 3, so that I'm able to move my bird about 3 times its size away from the anchor, which should be pretty good for starters. Next, I will define a position constraint, which will be a sk constraint.distance, which will take a range to a certain node. The range will obviously be sling range, and for the point, I will pass anchor. So now our anchor will actually function as an anchor for our bird node. Obviously, I now want to add this constraint to my bird by writing bird.constraints, which will once again be an array containing only this one constraint. So I'll pass position constraint, and this activates our constraint, but when do we actually need to deactivate it? Well, as soon as we launch our bird, it should naturally be able to leave this radius and fly all over my scene. So we should remove this when we let go. To remove it, I will just add the else part, in which I will just write bird.constraints.removeAll, which will remove all constraints from our bird to let it fly freely. Now we actually have to call this method in the appropriate places. And I will start in the add bird method, where I will right at the bottom, after adding the bird, call constraint to anchor with the parameter true to bind the bird to our anchor. Initially, when we add the bird, it should not move too far from the anchor when we drag it. So in the touches begin and touches moved methods, we won't change anything. Only in the touches ended method, we will, right before applying the impulse to our bird, add constraint to anchor with the parameter false to enable our bird to leave its radius and not be held back by any constraints. Let's run the app again and check all of this. If it worked, we should only be able to drag our bird in a certain circle around the anchor point, and only if we let go, it should fly away. Initially, our bird should also not be influenced by gravity, so it shouldn't just drop to the ground. The app started, and if I drag my bird here, I can see that after a certain distance, the bird doesn't follow anymore. So our constraint seems to be working. If I let go, we can't really see what's happening because of the simulator's lag. But our bird is gone. So it seems that we've launched it successfully. We should maybe take a look on an actual device to see if this is really as smooth as we would like it to be. Okay, I can now see my movement is way better, and as soon as I let go, it launches into my scene, so the bird. It would be nice, however, if our camera would now follow the bird, and we will of course have to add some kind of borders to our scene so that the bird is unable to fly out of the frame. We want it to collide with the walls as well as the floor, and that's what we're going to add now. And this will require some changes to our game camera.